Assalamualaikum warahmatullahi wabarakatuh. My name is Anfal binti Khazali. My matric number is 2010111119. Okay, today I would like to present the mini project. Okay, for the introduction, to improve the current phase margin of the system response, we implemented lead and lag compensators. The lead compensator increased the phase margin while the lag compensator decreased it. By carefully designing and combining these compensators, we were able to enhance the stability and performance of the system. Okay, for the objective of this mini project is to find and create a transfer function that is suitable for the mini project, to use the bird plot technique to illustrate the amplitude response and phase response of the system, to implement lead and lag compensators to improve the current phase margin of the system response. Next, to provide a detailed explanation of the compensators used to improve the current phase margin. Last but not least, to utilize Scilab to simulate and analyze the system for designing filters, generating bird plots, and the evaluating system responses, making it suitable for this mini project. Okay, using the transfer function, I assume the value number of the A is 7, B is 3, C is 8, D is 5, and E is 2. So for the value of K is 100. So getting substitute the number in this coding. Num is represent the numerator and din is represent for denominator. Okay, this is the value for phase margin, which is 92.86. This is the value gain crossover frequency, which is 15.88. The value for gain margin and the phase crossover frequency is infinity. Okay, by using this line, which is both TF, we can get this both plot diagram, which is the magnitude and phase of the frequency response. This is phase margin lead compensator. Okay, this is the calculation theory. Okay, this question is need to improve 10% for the current phase margin. Okay, this is the phase margin 102.15. Okay, this is the P max value, which is 24.29. This is the alpha value, which is 2.369. This is the tau value, which is 0.0065. Okay, this is the transfer function, which is 1 plus 0.0155 for the denominator, for the numerator, sorry. Okay, for the denominator is 1 plus 0.0065. Okay, we substitute the value of the transfer function. Okay, this is the num c represented of the numerator. Okay, 1 plus 0.0165 multiplied by s. Okay, this is for the denominator, which is then c. 1 plus 0.0065 multiplied by s. Okay, this is the operation line. Okay, this is a transfer function, the new transfer function. This is the phase margin for the lead compensator, which is 111.22. Okay, this is the gain crossover frequency, which is 34.08. Okay, same goes to the margin, the phase margin of the lag compensator, which is we find the frequency where phase is negative 77.8. Okay, in this part we need to plot the frequency at the phase where the value is negative 77.86 here, and we got the new frequency, which is 3.032. Okay, so we calculate to get the new alpha value for the lag compensator. Okay, this is the tau value, which is 0.438. Okay, the transfer function for the lag compensator is 1 plus 0.438s over 1 plus 1.864. Sorry, 1 plus 1.860. Okay, this is the line address for the operation. Okay, this is the transfer function for the lag compensator. We got the phase margin value, which is 97.74. Okay, this is the gain crossover frequency value for the lag compensator, which is 3.64. Okay, as you can see, this is the bird plot phase by the negative 77.85 degree here. So we get the new frequency to calculate the alpha. Okay, this is the last. Okay, we can compare. We can choose which one is improved by 10%. So here we can see that the value for the phase margin of the lead compensator is greater than the value of the phase margin of the lag compensator. So here we can say that lead compensator is improved by 10%. Okay, for the conclusion, we successfully achieved our objective of designing and analyzing a control system using the bird plot. Next, we know how to illustrate the amplitude response and phase response of the system. After that, we implemented lead and lag compensated to improve the current phase margin of the system. Furthermore, we provided a detailed explanation of the compensators used to improve the current phase margin. And last but not least, we utilized Scilab to simulate and analyze the system for designing filter, generating word plots, and evaluating system responses, making it suitable for this mini project. That's all from me. Thank you.